firework rocket launched vertically explodes into two pieces when it reaches the maximum height. Maximum height is the keyword here. Also, it is mentioned mass of x is greater than mass of y. Three statements are given. We need to figure out which of the three statements are correct. Now, the easiest statement out of all these is the third statement. Because if you look, it says the total momentum after the explosion has increased. This is not at all right. Why? Because according to the law of conservation of momentum, momentum before the explosion and momentum after the explosion are supposed to be equal to each other. Let us revise the law. So, according to the law of conservation of momentum, initial and final momentum are equal if there is no net force acting on the system. So, in this case, we have a firework rocket. Now, it has exploded, which means there is some sort of a force. Explosive force is an internal force. So we can say there is no net external force acting on this firework rocket. Hence, we can say initial and final momentum are supposed to be equal. So the total momentum after the explosion cannot increase, it will still stay the same. Next, let us look at statement number one. The kinetic energy of X is less than that of Y. Let's see. So the formula for kinetic energy, which we know, is half m v square. Now, some students might do this thing that they will say kinetic energy is directly proportional to the mass just because from this formula. But this is not correct. Kinetic energy will be directly proportional to the mass if the speed is constant. So, in this case, x and y, the speeds are not given. So, we don't know that are they equal or they are unequal as yet. So we cannot say kinetic energy is directly proportional to mass. This is incorrect. Let me repeat. We can use this proportionality. K is directly proportional to the mass only if the speed is constant, which is not given in the question. So we will use another formula for kinetic energy, which has a parameter which is a constant. So we know another formula for kinetic energy, which is equal to P square divided by 2m, where P stands for momentum. Now we just saw that the initial and final momentum are equal. So P factor, the momentum factor, is a constant. Since P is a constant, 2 is a number, it's anyways a constant. So from this we can say that kinetic energy is inversely proportional to the mass. Now going back to the question, it is mentioned that the mass of x is greater than that of y. So let us write this down. Mass of x is greater than mass of y. Since the kinetic energy has an inverse proportionality, so we will write kinetic energy of x will be lesser than kinetic energy of y. Let's look at statement 1. It also states the same. Kinetic energy for x is less than that of y. Hence, statement 1 is correct. Statement 3rd, we saw it was incorrect. Now, let us finalize the second statement. The magnitude of momentum of x is equal to that of y. Before we analyze this statement, can we figure out an answer just looking at the options? Since the statement 3 is incorrect, we can eliminate option B, C, and D. So three options are gone. We are left with option A. Hence, A is the answer, which means statement 2 is correct. Now let us analyze why this statement is correct. Magnitude of momentum of x is equal to that of y. So what are x and y in the first place? So there was a firework rocket launched vertically. It exploded into two pieces, x and y, when it reached the maximum height. Let us try to draw a diagram. So imagine we have a rocket on the ground. It is launched upwards. Now, when it reaches the maximum height, that is where it explodes. So let's say this was before the explosion, the entire rocket as it is intact. After the explosion, the entire rocket breaks up into two pieces, let's say x and y. So we know x was greater than y in terms of mass. Now back to the law of conservation of momentum, initial and final momentum should be equal. So we can write momentum of the rocket before the explosion needs to be equal to the momentum of the rocket after the explosion. So, what was the momentum of the rocket before the explosion? That is where we go back to the question to underline a keyword. It is mentioned that a firework rocket was launched, but it exploded when it reaches the maximum height. Now, try to visualize. Let's say you throw a ball up into the air. So the moment it reaches the maximum height, it will temporarily become stationary at the maximum height. So we can say momentum of the object at the topmost point is always zero. So going back to the analysis, we can write momentum of the rocket before the explosion was zero. And why it is zero? Because the rocket is at its highest point. So temporarily the speed will be zero. And hence we can say momentum is zero. This was before the explosion. Now, after the rocket explodes, it breaks up into two pieces, X and Y. Let's say X goes to the left hand side and Y goes to the right hand side. So, what will be the momentum after the explosion? We can write Px, which is the momentum of X, plus Py. But there is a catch. Remember, momentum is a vector quantity. We need to take the right sign into consideration. So x was moving leftwards. That means it should have a minus sign. So here, it is not just px. We will write negative px. And now if we simplify this entire equation, let's take negative px on the left-hand side. So we will write px is equal to py, which means momentum of x and y are equal, which was mentioned in the statement 2, which stated that the magnitude of momentum of x is equal to that of y. Hence, A is the right answer. So here we have been given a force time graph where on the y-axis we have the resultant net force, on the x-axis we have time. It is given the mass of the object is 1 kilogram and initial speed is 0. So let's write down u is equal to 0. We need to figure out the velocity of the object at the end of 200 milliseconds. So how do we do that? Since it's a graph-based question, either we do area under the curve or gradient. Let's see which one to take. So if I find the gradient will be y-axis divided by x-axis, force upon time, and area under the curve will be force into time. Now, if we go back to the impulse momentum theorem, J is equal to force into time, which is equal to change in the momentum. So in the current graph, force into time will give us the value of impulse, which is equal to change in momentum. And change in momentum can be written as mass into V final minus V initial. So let's try to figure out the area under the graph because that area will be equal to J. So area under the curve, this is a triangle. So area of a triangle is half base into height, half into base of this triangle is 200 milliseconds. So let's convert 200 into milliseconds multiplied by the height, which is 80. So this is the value of the area of the triangle. Now, if we simplify this entire left-hand side of the equation, we will get 8. And on the right-hand side, we'll write m. Mass was 1 kilogram. Final velocity we are supposed to find. Initial velocity was given as 0. So if we simplify, the final velocity will come out as 8 meters per second. Hence, the answer is option A. So this question is an application of the law of conservation of momentum, which is initial and final momentum are equal if there is no net force acting on the system. So here we have been given that a table tennis ball of mass 3 grams is fired with some speed from a stationary toy gun. Gun and ball are an isolated system. So we need to figure out what is the recoil speed of the toy gun and the total momentum of the system immediately after the gun is fired. Now, since we know that initial and final momentum are equal, so total momentum of the entire system after the gun is fired should be equal to the total momentum of the system before the gun is fired. So, how much is that? So, initially, the table tennis ball was stationary inside the toy gun. So, the toy gun is stationary as well as the tennis ball was not moving before the shot was fired. So, we can say that initial momentum of the gun and the ball system is equal to 0, which means that the total momentum of the system afterwards will also be 0. Hence, the answer is either A or C. We can eliminate option B and D. So, what will be the recoil speed of the toy gun? For that, let us try to create a diagram. So, let's say this represents a gun, and we have, let's say, a tennis ball inside it. Let's call that by A. This is before the shot is fired. So let me write before. Afterwards, what will happen? After the shot is fired, the ball will, of course, come out of the gun. And let's say it is traveling with some speed. And the gun, on the other hand, will be recoiled backwards. Let's say the velocity of that recoil is v. Let's say what all information is given in the question. First, the mass of the ball is given. So let us write mass of A will be 3 grams, which we can convert into kilograms later. Then the speed of the ball is given. Speed of A is 10 meters per second. Toy gun initially was stationary. The mass of the toy gun was zero point 0.6. So let us write down the mass of the gun is zero point 0.6 kilograms. And that's it. Now we find the recoil speed of the toy gun. So let's say the recoil speed is v, and we will apply just the law of conservation of momentum. So we will write momentum before will be equal to momentum afterwards. So we just saw that the momentum of the entire system. So the gun plus the ball system initially was at rest. So initial momentum will be zero. Afterwards, the ball was traveling towards the right hand side. So we'll use m into v. Mass will be 3 grams. So let's convert that into kilograms multiplied by the speed, which will be 10 positive 10, since the ball is going towards the right. Plus, the gun is also moving. The gun is recoiling. So we will write m into v. Mass of the gun is zero point 0.6 multiplied by the speed is v, but we will write negative v because that gun is moving towards the left hand side. And now, if we simplify this equation, let us try to make v as the subject. So we should get 3 into 10 to the power minus 2 in the numerator. In the denominator, we should get zero point 0.6. And if we simplify this, we get 0.05 meters per second, which is the recoil speed of the gun, which means option A is the right answer. Recoil speed is 0.05 and total momentum, of course, is 0.